So I've got to be honest, I did this question kind of by trial and error and it worked out pretty quickly. I will also go through a more careful way of doing it, which of course we should learn to understand if we need to deal with more complicated questions in the future that, don't have just multiple choice, etc., or, might really benefit from using a more algebraic approach. So I just said, right, what if Andy one of them was born in 2001. Let's just go with that as a starting point. Then the digit sum is 3, but they would be 7. This question's from 2008, so I've just subtracted 2001 from that. So, okay, so that can't be the case. What if I go with 2002? Because then they're going to become a little bit younger, but the digit sum's going to increase. So that doesn't work. What about 2003? Then 5 and 5. So that is a possibility. And if we go with 2004, then they're going to become younger again. The digit sum's going to increase. So that's the only one in the 2000s. We can now try maybe 1990 something. So maybe 1991. Then the digit sum is 20, and they would be 17. Let's go with 1992. So they're going to be, now this is going to be 21, but they're going to be, okay, they're going to be younger. So that, no, this isn't working out. And if I go with 1990, then they would be 19, but I'd get 18. I cannot have it so it's the same. Because if I go further into the 90s, they're going to get younger, but the digit sum's going to increase. So that can't be the case. Well, let's try the 80s then. Maybe that could work. What about 1981? Then now the digit sum is going to be 19 again, but they're going to be 27. All right, well, at least I'm back to having the age more. So I'm going to jump to 1985 because they're quite far apart. So that is 17 plus 6, 23, and they're going to be 15 plus 8. They're going to be 23. Okay, so that is the only, one in the 80s. If I go to 1986, then they're going to become a year younger. The digit sum's going to increase. We just take a look at the 70s, 1971, then the digit sum would now be 18, but they're going to be 29. They're going to be 37. There's no way that I could make these the same. And if I go into the 60s, we're talking about ages that are, again, more than 30, but the digit sum is going to stay low. So I can kind of rule these out by looking at that. It must be that one was born in 2003, one was born in 1985. Well, in fact, it's going to be Andy who was born in 1985 and Alice in 2003. So we can just subtract these 2 years, giving us a difference of 18. Andy must be 18 years older. Let's go for a more algebraic approach now. So let's imagine that one of them is born in the 2000s. So remember, this question was from 2008. So they would be 2008 minus 2000 and x years old. And x is going to have to be lower than 8. So that's going to give me 8 minus x. And if they were born in 2000 and x, then the digit sum is x plus 2. So I can see that 2x is going to equal 6, x must equal 3. Hey, I get the 2003 without trial and error. Let's now take a look at if they were born in the 1990s, 2008 minus 199x. So that is now going to be, if it was 1991, for example, then it would be 9 plus 8. So we need to do 10 minus x to work out how many years to get from x to 2000. And then I'm going to add 8 on. So I'm going to get 18 minus x. And then again, that must equal the digit sum, which will be 19 plus x. So that is 18 minus x equals 19 plus x. So 2x would have to equal minus 1. Okay, that we can reject that. It's not going to work. Then let's try 2008 minus 1980 something. So if it was 1981, it would be 19 plus 8. I'm going to be doing 20 minus x this time. And then I'm going to be adding 8. And then that is going to equal 18 plus x. So 28 minus x equals 18 plus x. So 2x is 10 and x is 5. And that means they would have been born in 1985. Okay, it's got to be said, that is a really nice algebraic approach. Rather than just trying things out, we can be absolutely sure and we haven't missed any. If you then take a look at 2008 minus 19, let's just go with the 70s, then it would be 30 minus x plus 8 equal to 17 plus x. We'd get 38 equals 17 plus 2x. So 2x would equal 21, and x would equal, okay, in this case it would be a decimal, but the thing is, this here is going to keep increasing now, and x is going to get bigger, but remember, x actually has to be between 0 and 9. So if you if you go with like the 60s, for example, you'll get an even bigger number, x will get bigger. We can rule out any other possibilities. A little bit like I was doing over here. I was just saying, look, the ages are going to get really big. There's no way that digit sum can equal it. I haven't like proved it, you know, conclusively, but you could do 2008 minus 19yx and investigate that, but I'm not going to do that for I've gone into quite a lot of detail with the algebra. We found the 2 years and I'm pretty happy with that.